Hey guys, let's start. Can everyone hear me? Okay. We will start with where we left off yesterday. So last day we did like two relational algebra. One was select, which is filtering operation, and then second was projection, which was like selecting a subset of attributes. We will now today we will do start with union. So by union, like if you think in terms of set theory, if you have two sets A and B, union should give you A union B. So just to recap, we have these tables are the tables that we created last day. And suppose I want to do union for two tables R and S. So the way we do it, it is select star from R union all. That's the keyword. Select star from S. Right? So it unifies everything over here. A better way to do would be select star from R union all, select star from R1. So if you see what is in R, these are all the values present in R, and what all in R1, these are all the values present in R1, and it just appends all the value together, union all. So you get all the values appended when you do R and R1, right? So this is pretty simple. The next operation is intersection. So in intersection, what we have, the inputs are two relations say R and S, and the output is a new relation, let's say RS, which is intersection of the two relations, like similar to set theory. You can try that if you want. Union will work, I guess. We can do that. Let's do that. Okay, so T. Okay, so it should have same number of columns. Only then it works. The union. So this is done. Intersection, it does the intersection of two, where is that? So now let's talk about intersection. It takes to input as two relations R and S, and output is intersection of these two relations, right? The way we do it in SQLite is to use the intersection command. You do select star from intersect select star from S. So since there is nothing in common, let's see R and this is S. There is nothing in common, so intersection won't work. But if you do select star from R1, then you get intersection of everything. So this was R1 for your reference. So this is R1, A1, B1, A2, B2, and A3, B1, and this is R. So it takes the common elements and it does the intersection. Next thing, these are like pretty simple, so I'm just moving very fast through it. Next thing is difference, which is very similar to set difference. So the input will be R and S, and output is difference of the two sets, which is R minus S, right? So very similar to sets, you have set A and set B. Difference will be everything in A which is not in B, or everything in R which is not in S. The way to do it is use the except operator. So you do select star from R except select star from R1. So you get everything. So this was the intersect, and this is the except operator. What all is not there, right? Then there is something called product operator. It just does a product of two inputs. So if you have R, S as the input relations, then output is all possible combinations of R times S. Way to do it is use cross join. So you do select star from R cross join. Let's select cross join S. So you see, like so say R has 5 columns and S has 3 columns, then total it will be 15. 5 times 15, there will be 15 output values. So for each entry of R, all the columns of S will be printed, and so on and so forth. So you see over here, this is the first entry of R for this. So this entry continues till this part, and all the values of column S is printed. Again, we do the same thing for the next entry of R, we print all the values for column S. So it's like all possible combinations for R and S, right? Now let's come to a special operator, which is join. And especially we are going to talk about natural join. So join, it does, say you have two separate columns, right? Let's see over here. Now in R, you have column B, which is common to both. Column B is common to both R and S, and you just want to output the values which are common, only like for which the value B is common across R and S, right? So way to do it is use join. The command is select star from R join S, and then you specify how do you want to join both the columns. So you say R dot B is equal to S dot B. So join R and S based on the values of the column B that match in both the cases. So wherever the both columns match, we will do a join. So you see, like this is the column from R, this is the column from B, and this will always match. And it gives you the entire output. Now you don't want the entire output, you just want the projection. So you can do R dot A, R dot B, and R dot C, and S dot C. So you only get 3 columns, you don't get 4 columns altogether. So over here I'm using projection plus join operation. Is this clear to everyone? Any doubts?
So how is the join operation working then? Is it just appending the two common columns, like the B?
It is not
Is it?
appending the two it's comparing the two columns, and it's comparing the two columns based on the condition that you have provided. So the condition that I have provided is that the bth column value on R should be same as the bth column value in S. So based on this condition, it does the matching and it does the join for two relations. Is it clear?
So how are there so many outputs? Like, shouldn't it be how many ever columns are there and how many ever rows are there in B?
Right. So, but B1 it matches multiple rows, right? So B1 matches with C1 and B1 matches with C2 as well. So it does A1 B1 B1 C1 A1 B1 B1 C2, right? Then it will do A2 B1 B1 C1 A2 B1 B1 C2. So it will first match the values which is same, and then it will output all the possible combinations. Does that make sense?
Yes, sir.
So who was asking the question?
I was.
Um, yes. Did that help to you, or like should I repeat again?
No, that helps. Yeah, that's fine.
Are you sure?
Yeah.
Okay. And over here, what I'm saying is that okay, I don't want to print all two columns because these two columns are redundant. So you just print one column, right? And you can do like if you do like say join on C, like this will not work because nothing will match. So you get an empty result, right? This is pretty obvious. So let's check what all tables we have. If I do select star from T, you have A1, B1, C1, right? So one way you can do join is you can do R join S, and you can say that R dot A, R join T is T dot A, and R dot B is T dot B, right? So you only output the values which matches. Oh, sorry. So it only outputs the value which matches, right? So A1, B1, since there are two values for A1, B1 in R, so it outputs it twice. So A1, B1 is over here, A1, B1 is over here as well. So it treats these two as separate entries. So first it outputs A1, B1, C1 for the first entry, and then it outputs A1, B1 for the last entry. But remember, if you did join on B, it would have only matched on A, and then the outputs will be a lot much, right? So now if you only do match on A, then this is the T column and this is the R column. Then only A1 and A2 is there, so it will match these four values only. And so you get four outputs. So A1 B1, A2 B1, A2 B2, and A1 B1. So A1 B1, A2 B1, A2 B2, and A1. So same outputs are there. Does this make sense? Like based on what conditions you are mentioning on join, that's how the join will be done by the tables. Okay. Now if you have any doubt, please interrupt and we can discuss it further. Now there is something called natural join, right? So natural join, what it does is it looks for common values in two. So if you have say two relations R and S, then what this does is it looks for common attributes in two relations, and does join based on those two relations. So like if I do select star from R natural join S, so the common attribute is B, so it will match only the B column and it will do a join. So this join is same as join on this thing, and this thing will be the same, right? sorry, r dot b is s dot b. So these two values will exactly be identical. So say this is your one relation, right? This is your one relation, and if you do a difference, right? So we have looked at except operator, and if you do difference using the natural join. Syntax error. What is the issue? So nothing is present over here. Like it's a completely empty set because this.
So could you please show natural join again?
Pardon?
Natural join again. Can you explain, please?
Okay. So in natural join, if you have two relations R and S, right? Now R can have multiple attributes and S can also have multiple attributes, right? Natural join says that you only select the attributes which are common to both R and S, and then you join based on that. You equate those two attributes and you do a join. So say R has attribute A, B, C, and D, and S has an attribute of B, D, F, and G, right? So what are the common attributes in this? It's a question. So who was
B
speaking?
and D.
So bottom is not visible actually.
Okay. So now you can see it. So what are the common attributes for R and S? B and D are the common attributes.
B and D. Yeah, B and D.
Right? So it will only look at attribute B and attribute D, and it will wherever the both these two attributes match, it will do a join. So wherever the attribute for B matches B, R dot B matches S dot B, and R dot D matches S dot D, it will take that output. Is that clear?
Okay, fine. Yes.
So if I do select star from R natural join T, right? So in R, the columns are A and B, and in T, columns are A, B, and C. So it takes A and B as the common column, and it does the join. Let me quickly show that. Select star from R. So this is R, and this is T, right? You can see. So common attributes are A and B, right? And so it will pick A and B together and match the values for A and B. Where the two values match exactly, it will perform a join. So the only values that match exactly are A1 B1 and A2 B1. So it performs the join based on that. That is natural join. Is this clear to everyone?
Yes, sir.
Okay, so this concept we will use the join concept a lot while using query languages. Now, one more thing is, so you get this point, right? Like every time when we do some kind of relational algebra, then input is a relation and output is also a relation, right? When we do select star from T, then input and output are the same relations. But when we do some projections, or we do intersect, or we do difference, or we do filtering, so if we do select star from R, where A is equal to A1. So this is another relation. Input is the relation R, and output is some other relation, right? Say R prime. So every time we do an operation, we input is one relation. So this is how it works. keep this process in mind. There are relations R1, R2, so on and so forth till Rn, which is the input. You perform a relay operation on these values and you get a final output as a relation O, which is the final output, right? So over here in the filtering, the input is relation R. You do filtering operation, and output is this relation. In natural join, the inputs are two relation R1 and R2, and you get a single relation as the output. So we always play in terms of relations. Input is one relation, output is another relation, right? So one thing to observe, I don't know how to make to go at top. Okay, just let me Google once. Clear screen. Okay, it does not have any clear command. Okay, this works. Okay, now this is fine, right? So I was saying that input are multiple relations and output is one relation. Same thing happens with natural join. Inputs are two relations, output is the join, and like operation is join and output is one relation. Now a thing to observe is if I do this query, right, select star from R natural join S where A is equal to A1, right? This is one operation that I can do. Another operation I can do is select star from R where A is equal to A1 natural join S. This is another operation I can do, right? So first question, will they produce the same output? Guys, I'm talking to you.
No.
Why not?
So in the first relation, it'll first natural join them and then select from the table where A equal to A1. In the second relation, it'll first separate the table A to the table where A equal to A1 and natural join that with S.
Yes. So ultimately we want A equal to A1, right? So why will this not work?
This will work, sir. It will give same output.
Yes. So why did you guys? Yes, the process is different, but the output is same. That is exactly my point. Over here, first we are creating a bigger relation. So this is happening first. You're joining the first, and then you are doing a filtering. So in number one, you're doing the operation works in this way. You join first, then you do filtering operation. In second process, you are doing filtering first, and then you are doing a join, right? Only the process is different, but ultimately we will get what we want because we are restricting that we only want values for A equal to A1. So it doesn't matter how you do it. right? But the key important thing to notice here, okay, let me just run this query once for the sake of it. So I don't know why it does not like this. Okay, so it should be something like this. It should have worked the first way as well. Let me see if there is indentation issues. Okay, so this does not work, but the other way it works, which kind of makes sense. So let's see, these are the two outputs, right? So this is one output and this is the second output. For sake of it, let me do this, right? And then let me do this as well. Okay, what happened? Oh, it clears the output. This is one output and this is the other output, right? So in the first case, we are doing join and then filtering. In the second case, we are doing filtering and then we are doing join. Is this correct? And the output is exactly the same. There is no difference in the output. But one thing to remember, is there any doubt till here? Like, let's first clear this up. Like, anyone who did not follow or did not get why is this happening? Okay, okay, cool. So one thing to note is over here we are doing in the first case we are doing join, right? So we are creating a bigger table, and in the second case we are first doing filtering and then we are doing join. So time complexity wise, what do you think? Which one will be faster, the first one or the second one? Which part, Ritik?
The second one.
Second one.
Ritik, which part do you want me to repeat? The last one. Which last one? Can you be precise? So I'm not following, like, which part exactly. You did not follow join filtering, filtering join, or? So let me repeat the entire thing just for sake of it. In the first thing, okay, in the first command, like this command, we are first doing a natural join. Don't look at this statement. Okay, look from here and below. In the first command, we are first doing a join on the two tables, and then we are doing a filtering where a is equal to a1. So this is the first command that we have. In the second command, we are first doing the filtering on R. This is a new relation that you get, and then you are taking join with S on that relation, right? So the second is we are doing filtering and then we are doing join. So the first premise was, like, if the filtering criteria is same, the output is always the same. So that is the output that we get. Like, this is the output 1 and this is the output 2. So both the outputs are exactly the same. Now second question was, Why? Yes, bracket gives higher priority to the command. So the second question was, which one will be faster? The operation 1 will be faster, or the operation 2 is faster? So the answer is like operation 2 is definitely faster, because you are doing filtering, so you're reducing the number of rows, and then you're doing a join, because then you have to join on less number of rows. If there are multiple rows in both the relations, then join will take a lot of time. So for example, let's say, just for sake of argument, let's say you have R, which has 1 billion tuples. You have S, which also has 1 billion tuples, right? And then you have filtering criteria, which will give you 1 tuple in the output, right? Now, if you do a natural join, then in worst case, natural join will give you 1 billion times 1 billion. This will be the output if you do natural join. So if I do join and filtering, in this case, what it does is it takes the join, which is 1 billion times 1 billion, and then it does filtering, then it gives 1 tuple as the output, right? In the second case, it will do filtering. If we do filtering followed by join, then it gives 1 tuple, which it then does 1 times 1 billion as the natural join, right? And it gives you the output. So clearly in the second time, the speed will be much faster compared to the first time. In future, when we are trying to write the queries, we will see how we can do filtering first and then do join, so that our runtime is pretty fast. Is this part clear to everyone?
So why did that second command not work? Like
Which command? This one?
yeah.
It can work, but you need to select star. Select star from this entire thing. This will then work, I guess. So the reason was, this is an output, right? This is one relation, right? And this is another relation. Now, what I was doing was, I was doing R1 natural join.
Yeah. Okay.
Yes. This does not make sense, right? So you need to do select star in the beginning as well. Is everything clear? Okay. Now, so like the language that we are seeing, that all the languages we did select star, I've gone through a lot of them. We call it SQL, right? So this is like nothing but structured query language. That's the full notation for this. Now this is the language that is like the high level language. If you remember from the previous class, we said that relational models will define a high level language for the users to interact with the low lying details. So this is the high level language that most of the relational databases management systems define. So MySQL they define their own form of SQL. SQLite defines their own form of structured query language. There are minute differences in all of them. Postgres, Ingress, they also define their own kind of MySQL. And then we define procedural operations on using the structured query language. So we say that from R you select this thing, right? And then we also looked at how do we create table, how do we define our schema, how we can add drop tables, and some basic operations like filtering and things like that, Right now we will look at advanced query language, advanced SQL. Right now, if you want to do aggregation operations, then how are you going to do it? So let's exit this thing and I will open the IMDb database. Okay, and now let's look at advanced SQL. We will do, let's first look at the tables that it has, right? Oh, they were charts. Okay, all clear. Now these are all the tables that you have. Way you can look at tables is do schema AKAS. This gives you like what this table contains. So it contains title ID, title, region, language, and whether it is original title or not. We can also look at title table, titles table, and it has title ID, type, primary title, original title, or whatever, and things like when it was it premiered, runtime minutes, what genre it belongs to, so on and so forth, right? So let's say I want to count the number of entries that is present in the titles table, right? So the way you issue a command is you do select count star from titles, right? And it gives you a number of entries that is present. So these are the number of entries present in the title table. Right? So these are the number of entries. If you do count star from titles, you get the number of entries. So this is one aggregation operation. Okay, now let's say if you want to list all of them, right? Select star from titles, right? Now since there are so many entries, you don't want to list all of them, right? You just if you want to visualize the data for a few of them, what you can say is you can use a limit operation and you can say limit 10. If you issue a command of limit 10, it lists only the first 10 tables and you can look at it, right? Does this make sense? The second one, count star just gives you the count of number of rows, and limit 10 says like, okay, only print the top 10 rows in the output because I don't want to see all the rows. Now this also gets a bit messy. Then you can do primary title, original title. So it only gives you primary title and the original title, right? So it gives you, this is the primary title, this is the original title, so on and so forth, right? So this is clear. The limit is clear. Now let's say you want to sort it based on limit primary title. So what you can do is you can do select star from title, or you can say select star from primary title. Let's see what all they have. Select, let's say I pick primary title over here, premiered, runtime minutes, and genres. From titles, and I limit 10. Just want to show you how the data will look. So this is how the data looks like, right? And now let's say I want to sort based on the primary title it has. So what I do is I say that select primary title, premier, runtime, genres from map, and then I say order by. How do you want to sort? That you specify. So you say order by primary title. So it sorts based on primary title, but you don't want to see all the outputs. So you append the title limit 10. So it orders by primary title and then it limits only the top 10 results. So the way it does the sorting is based on ASCII value, right? Another way you can do is you can sort by genres and you can limit 10. By default, it sorts in the ascending order, right? So you see all the action A's first over here. Now, if you want to sort in descending order, you can say order by genre descending. I think DSC is the short term, or DESC. I don't know. I have to check. Okay, it's DESC. So it sorts in descending order right now. Dash slash n, I guess that's some filtering that they have over there. Now, suppose first you want to sort by genres in ascending order, and then premiered by in descending order. The way you do it, you say order by genres ascending, then you do premiered descending, and then it sorts genres in ascending, and for everything it sorts premiered in descending order. So thing to note over here is that you can have multi-level sorting. First you sort on first column, then you sort on second column, then you sort on third column, so on and so forth. Like, is this clear to everyone? Like, these are pretty simple things. So I'm moving fast. If you want to slow it down, just let me know and I will slow the pace down.
Can you please explain how does multiple sorting works? Is it like similar to how radix sort works? Like in the if I sort by genre and then by premiere, so
Hmm.
uh, then the all the action genres will be sorted based on premieres.
So so when I say sort by genre and then by premiere, right? What does it mean? Like, you first sort everything by genre. It is very similar to radix sort. You sort everything by genre first. See, all the actions will be on top. Then but within actions, it will sort by premiered.
Oh,
It
okay.
it's not like after once the action is solved or once the genre is solved, it will sort it independently. No, it will maintain the first ordering. So
Okay.
it will maintain the ordering for genres and then it will do the ordering for premiere as well.
Okay. Got it.
Okay, Sakshi. So what I'm saying is, let's say you have. Let me do. Let me take an example. You got it? Okay, cool. Any other questions using order by limit, things like that? Okay, let's move on. So we did count. Um, so you see that we have a lot of genres, right? And if I do select, you can do a select count of genres as well from titles. Now this will give you same value, but I just want the count of distinct genres. I don't want the count of all the genres. Or first, let's say I just want to output distinct genres. I don't want to output all the genres, right? Because it will output all the genres from all the columns. So the way to do it is use distinct keyword. So it outputs all the distinct genres that is present over here, right? There are no repetitions over here. So since it's too much, I will just do limit 10. So it outputs 10 distinct genres, and you can also do order by order by. So it gives you all the thing, right? I'm not sure why it outputted this multiple times. Um, it should have given this only once. Okay, so one way you can do is you can do count of distinct genres. That is one thing. I will come to this later. So you see, there are only 2000 distinct genres that is present. Whereas when we did the original, when we did like count of genres just, then it was like 2 million, I would say. Yeah, 2 million genres. So distinct gives you all the distinct outputs. Now, why is it showing the same output multiple times? That is something I don't know.
I guess this output is truncated because when I'm running on my terminal, then it's showing the full length, and that's why it's looking the same thing because the different characters are not getting displayed.
Okay, okay. Thanks for clearing that. So what if the top three genres have A's and B's? Then how they will be sorted? So it first it will be sorted by A. Then within A they will sort the premiered, and then in within B it will sort the premiered. So it is like something like let me go over that thing again once. So say you have something like this: A1 B1 A1 A1 B1 C, or A1 B1 C1, then A1 B2 C1, then A2. Let's do this. A2 B2 A1 A1 B2 C1, and then you have A2 B1 C1. This is the columns that you have, and then you say the order is order by A followed by B, followed by B, and you want to say order by A ascending and followed by B descending, right? So the final ordering for this one will be, once you say A ascending, so it will first take all the A values together. So every A1 will come together first, then A2s will come. Right? And then it says you're ordering by B descending, then over here B2 will first come. So with B2 you have C1, right? And then B1 will come. With B1 you have C1. Why did I kept C1? I don't know. Then over here it will be B2 and C1, and over here it will be A2 and B1. I guess this should be pretty much clear, right? Why genres keep it even after distinct? So sure, yeah, the output was truncated. It did not have the entire output. Like someone confirmed, like when they were printing in their own terminal, they could, oh shit, they could see their output. They could see the correct output. So I am not sure why the output is truncated on my terminal. I need to look at some settings, but these are all distinct genres. That is assured. So a way to do it is select distinct premiered from titles. So you see these are all distinct titles that you have, right? There are no repetitions over here. And you can say distinct titles order by premiered limit 10. So it will give you 10 distinct titles in ascending order and limit 10. So there are some null titles as well. So that's why you see an empty output. So you can say from titles where premiered is not null. So when you specify something as not null, it says that, okay, remove all the, by default, if you don't provide a value to a column, it takes a default value of null. So we say that only select things which are not null. So it removed the space in the end. So the white space that you see over here, it is like basically it represents the null value, right? So is this clear? Like the output is always distinct. The distinct command works. Okay, cool. So distinct is done. We looked at count. We looked at all the things, and now let's look at other more stuffs. So suppose there is a column called runtime minutes, right? And you want to find the maximum runtime minutes that is present. So you do max of runtime minutes from titles, right? So it gives you the maximum output. So this is the maximum runtime minute of any movie that is present. If you do a min, it will give you minimum runtime minute, which is 0. Other commands you can issue is average. So it gives you the average runtime minute. So we did max, min, count, average. You can also do a sum. So you can do a sum of runtime minutes and it gives you the entire sum, right? So this should be pretty straightforward. Any questions till here? Okay. Also, let's look at some string operations. A string operation is now suppose you want to perform some regex match. Select star from titles, or let's look at some other table now. We have looked at titles. Let's see people. So people as name bond died. Okay, let's work with people now. It would be interesting. So let's look at what is there in people. Just do limit 10 and you just get a rough idea how things are. Okay, so we have person ID, name, bond, died. Cool. So now I want to get the name of all people whose name starts with Brad, right? So I can do select star from people where name like Brad, and you can do percentage over here, and that's it. So percentage over here, it is like wildcard expression. It matches 0 or more strings all the way towards the end, right? Let's first do limit 10. So you don't want to output. So you get all the values, which starts with Brad. You can also do order by name. So you get all the values in the ascending order. Okay, they don't have anything. That's sad, right? So this is that. Now let's say it starts with Brad and it ends with let's say the letter N. So you say just percentage and N. So everything over here it ends with the letter N, right? You can verify it.
What
So
does
is this
percentage do?
percentage? It's like wildcard. It matches 0 or more characters,
Okay, okay.
right? Any question with regarding string matching? Okay. So I guess you have one more lecture starting at 9. I will just check if DPP doubt clearing session is there, right? So I don't know. You can use anything you want. Yeah. You can use percentage N. Percentage N means like it should end with N. Ritik. ING mean percentage ING means like percent ING means it should end with ING. So this is like star. In regular world we use star, right? So in SQL we use percentage. That is. What if we didn't use, so it will try to match exactly. So if it does not get a match, it will not output anything. So only these are the values it will output. It tries to do an exact match, or it will do a regex match. Any other question? What is plus in SQL? Where did you find plus?
So no, in regex, plus is for one or more characters, right? So what is that in? Is there anything like that in SQL?
I guess there is something called underscore. So underscore matches one character, and then you can do percentage, I guess, something like that. So underscore will match exactly one character.
So no, I mean one or more. Like, is
So
there
this is
anything
one.
like one? Okay, yeah.
So underscore is matching one character. And if you do percentage, then it matches 0 or more characters. So essentially underscore percentage is 1 or more character.
Yeah.
Right? Cool. So this is done. Now we will look at group by. Let me just check if I've taught everything. Yeah. Now let's look at more advanced SQL. We will do group by, right? Now the way we do this is, will we cover nested queries in some upcoming? We will cover nested. We have already covered it, Hemant. So, but we will do nested queries as well. Sure. Group by. Actually, the plan was to do it today, but like it was only 1 hour class. So let's see. We will cover nested queries as well. Now let's say the question is, you let's look at the titles table, right? You have runtime minutes, genres, and my question is, you want average runtime minutes per for each genre. So let's say this is the query, right? This is the query that I want to solve. Now, if I do this, select average of runtime minutes, comma genres from titles. What do you guys think? Will this work or not? No? Why not?
So it's taking average of all the genres together.
Yes. Yes. So this won't work. Or even if it works, it gives you the wrong output, because let me explain this in the sheet, because it's not always trivial to understand. So you have two columns, right? One is runtime minutes, and then another thing is genres, right? Now runtime minutes, some values for runtime minutes could be 116. Genre is say action. Then it is 128. This is for comedy. And then it is like 95. This is for thriller, right? Now it again has one more, let's say 60 minutes, and this is for short movies. So let's say 115. This is also for action, right? Now the way I want the output is for action, I want average of 116 plus 115 over 2, right? This is I want, and for the rest, I just, since there are only one values, I just want only one output. But remember, when I taught you average, what average does is, if you do average of runtime, then it averages over all the things, right? It will take 116 plus 128, 95, 60, 115. It will do average, and it gives you just a single output, right? You will get some output as average for the entire thing. Now this average is for all the genres, and it's not agnostic to genre. It is agnostic to the genre, so it does not know which genres to pick. So when you write in the SQL query, when you write average runtime comma genre, the DBMS does not know which genres to pick, so it will randomly pick one genre and give you the output. But the average it gives, it's the average for the entire thing and not for individual genres. But we want average for individual genres. So the way to do it is using group by command. So way you write it, is this clear to everyone why this will not work? Let's first discuss that.
So you said it will do group by like runtime for takes average runtime for all. Can't we do like for some only, like if we want only thriller and short?
No, so my initial question was, I want to output the average runtime minutes for all these genres. So how will you do that? Right?
Okay.
So there is one output for action, one output for comedy, one output for thriller, one output for short, right? Since I have 4 genres. So this is not doing it. It's taking average for everything and it's giving you one output. But I need 4 different outputs for 4 different genres. Does that make sense?
Okay, sir.
Are you sure?
But we don't have average runtimes, right? We have only runtimes,
Yes.
like
So
as
that's
we
what
mentioned.
So what is the average runtime for action?
Uh, like 116 plus 115 by 2, right?
Yes. So we want this value, right?
Yes, sir.
So this won't work. You agree with this, right?
Yes, sir.
So there is so I'm coming to the point, like we can make this work using the group by. I will come to this later quickly. So this won't work. It just gives you a random output. Okay. So in some SQLite, this does not work. In my SQL it won't work, but in SQLite it works, and this is just random output. This is not the average for the genres, so don't get confused with that. The way to do this is use group by tag. You say group by genres, and let's say you limit 10. So now it says that for action, the average runtime is this. For action and something, this is truncated. I don't know why. The output is this, and so on and so forth. So for each specific genres, you get a different output, right? Is this clear to everyone? Okay, cool. So let's look at more complex query.
So the above output is of the first output is not only for action, drama, and family, right? That
No,
45.23 something.
no, it's the output for the entire thing. So let me show it to you. So see, if I do the entire average, the output is the same. This is some random value that SQLite is picking. If you try to run this query on MySQL, it will fail.
Okay.
Okay. And over here, when you do group by tag, then it does things like this. Okay, nice. Now let's look at schema for titles, right? So it has premiered, ended, right? Now let's say you want to count the number of titles for each primary title, like how many other titles are present for, I guess there was a table for that. I guess AKAS. So title region is original title, right? So now for each title you want to count in how many languages it's being made. So a way to do it, you will do a select count of language, comma title, group by title. Sorry, from AKAS. And you can specify this as num, right? And then you can say order by num, descending, and then you can limit on it as well. So you see, for our life, it is made in 23 languages. The string, it's I guess it's a beautiful mind. It's not showing over here, and it's made in 22 languages, right? So a thing to note over here is you can reference the output column as some variable num. So it shows this as num, and then you can use that variable in your future uses as well. So I've used it over here, like order by num in descending fashion, right? So this should be pretty clear. Now the question is, like, I want to get the language per region. I want to know the count of titles per region and per language. Count of language per title and per region. So this is the query that I want to execute, right? So it's like multi-level group by, right? So you first, for each title, you select a region, and then you do in that region for that title how many languages it was made. Is the question clear to everyone, like what I'm trying to do? A way to do it would be just to use group by on two ways. So you say count of language, title, region from, okay, title region from AKAS. So you can say this as num again. Group by title, comma region. So it groups by title and then by region. Then you say order by num, and you say limit 10. So it says, okay, I should do descending. So it says this title in this region was made in 18 different languages. This title in this region was made in 14 different languages. This title in this region was made in 10 different languages. So is this part clear to all? Like we can do multi-level grouping as well. Anything you did not understand? Guys, if you want me to explain it again, I can do that, but please ask if it is clear. Okay, cool. Nice. So one thing to remember in mind is, like, if you are using aggregate functions, please explain multi-level grouping. Okay. So I'm saying that so was the question clear, Pranav? What I want to do? let's start with that first. Okay, so what multi-level grouping is doing is it first groups by title, right? So over here you see that this grouping is by title, right? So in for title our life, it is in 23 different languages, but within 23 languages there could be multiple regions where it was created, right? So in 23 it could be like 6 was in region 1, 7 was in region 2, and 10 was in region 3, right? So there were 3 distinctions, right? Now when I say group by region as well, so it breaks that down as well. Got it? Yes. A better, I think this is not a good visualization. I should do order by title region. Order by title region. Then descending. Okay. So if I remove this, so for all region, is it possible to find count per region and count per title? Means two diff counts can be maintained. So I did not get your question, like count per region and count per title. Oh, I see. You have to maintain two different queries for that, because group by will group it together. It and the aggregated function doesn't work that way. So a thing to remember over here is that when you do when you apply your aggregated functions over here, when you use group by, so over here I'm using group by, and you are outputting count and some other values over here, right? Other values as well. So all the attributes on which you're not doing aggregation, it should come in the group by section. So if I'm doing title region and I'm not doing any aggregations, so it will come over here, group by this and this. So that way it's pretty easy to remember, like how to do group bys. Okay. We can't do it in one query. Yeah, we cannot do it in one query. Count per region, count per title. No, you can't, right? Because you are using group by on one thing and group by region in one case, and using group by title in another case. So in one query, if you do by group by region and title, it will do multi-level grouping, like same title and same region. What is the value, right? Okay, so this is done. Let's look at nested queries now. Right, we will start with this. So it's very simple thing. Like if you get the notion like of operations, right? The way I defined, you have multiple inputs R and S. You do a operation on this, and you get a new relation O as the output, right? So nested queries, they exploit this thing only, right? And one of the things that nested query does is this, and there are other things as well. So let's say let's start with let's look at the tables first. Tables. Let's look at a schema for titles. It's a good thing. Let's also look at schema for okay, people So people has, and let's also look at schema for crew. So let's understand what is happening first. In people, you have a person ID, it has a name, born, died. Now in crew, it has title ID and person ID and a category. And then the crew is related to title via title ID. So if I want to do like what person, like all the person named Brad, like list all the titles that he has worked on, right? So how will you do how will you do it? Like any answers? So you have three tables, right? People is the table for people. What's the name, age, born and died, right? And titles is what movies are made. And the crew is the link between people table and title table. So it says like this person worked in which movie, right? So now my question is, I want to list all the titles, um, list the first 10 titles which was performed by person Brad. Let's pick a name. 1 minute. Select star from people. So say I want to list all the titles. List, I would say, the first 10 primary title in chronological order, which was performed by this guy. So think about it. How are you going to do it? Like based on you have relations between all the three tables. So how are you going? You can use natural join in this case. So like I will give you guys 5 minutes to think about it. One thing is before that, let's say you have three relations R, S, and T, right? And you do natural join R. You do R natural join S, which then you do natural join T, right? So it does natural join on all three tables. Like you can also specify the ordering. So you can say that first do natural join on these two, and with the output that you get from these two, you do natural join with R. So using crew, people, and ratings. Sorry, crew, people, and titles. Like this is the query that you need to perform. Like how are you going to do it? Just think about it for a while. I'll give you 5 minutes, and then we can resume. Like just think about it. Okay, guys, did you tried it out on your machine? Does anyone has any solution?
Can we do a join of the three tables and then say like select star from join of all the three where name equals Bridget Bardot?
Yes. Select name movie year as num from where select star from PK. Where is title Gordon? Name is title. Oh, the titles table. So the idea is to do join for all the three tables. You can do select star from where is people, natural join. What was the crew, natural join. Where is that? Titles, right? Where um, then you do where name like Bridget Bardot, where name like Bridget Bardot, and then you say order by premiered descending, and then limit 10, right? And I don't want to do select stars, so I'll just do primary title. And I just want to do the premiered as well. Did I miss something? So it crashed because it takes a lot of time to do join on all the three tables. I don't know what happened in the screen. 1 minute, guys. So is this clear to everyone? Like it took a lot of time to do this, but it finally gave you the titles and the premiered one. Okay. Now a way to do this.
Doubt.
Yeah.
So what is crew? If you do crew natural join people, will that make a difference? Instead of people natural join.
No, why will it make a difference?
So what's exactly happening when you do natural join? I'm not clear on that.
Natural join, it tries to do the matching. You know what natural join does, right? Or is that part not clear?
No, like the whole join concept is a bit shaky.
So so these people, right? and then there is crew, right? So what are the common columns in crew and people? Person ID is the only common thing, right?
Yeah.
Yeah, like talk with me and things will get clear. So person ID is the only common thing. So when it does the natural join, it will join the rows for this with this, where the person for it will join only for those rows where person ID is common, right? Does that make
In
sense?
the sense, like only the people who are there and
So
the
so
people will be.
one person can have multiple titles, right?
Yeah.
Let me just quickly show it in the board. I guess that will help. Say you have PID, person ID, right? And then there is name, age, right? And date of birth, DOB. This is the table 1, person table, right? And then
Yeah.
you have table 2, which is crew. You have title ID, TID, PID, right? And there is some other thing, right? I don't remember. What is that?
Categories or
Category, right? Category is there. Let's say only category. So over here in PID, you have P1. So this is the primary key, right?
yeah.
P1, you have name, age, and date of birth, right? And in title ID, you can have like for P1, you can have title T1 and category C1. Then for P1 again, you can have title T2 and category C1 or C2. Again for P1, you can have T3 and category C1, right? So
Yeah.
when you do a join, it creates a bigger table like PID, name, age, DOB, TID, category, right? And it does join based on the PID column. So it will write PID everywhere over here. And this values will be common because it was the primary key for T1, right? So these values will always be same. And then it will have T1, T2, T3, right? And then C1, C2, and C1. So this is the natural join. It's joining the two tables based on this person. So let's say you have some other person P2, right, which has some other values, and over here some other titles are present, T5 P2, T4 P2, so on and so forth. So there will be two columns for P2 as well. So over here it will be T5 and T4 and some categories and other values. Did that make sense?
Yeah.
So let's say that hypothetically, like this one also had a category column, right? And it was at C1 and C2, something like that. So when you do natural join, then we'll join only on P1 and C1. So this value won't be there. This was C1 originally, right? So when it does natural join, so it takes PID and category. So it matches, okay, P1, C1 match with these two columns. So it will output only these two columns, this one and this one. It won't output this one because category does not match. Did that make sense?
Yeah. Okay.
Okay, so when we do natural join over here, then it joins based on these two columns, right? It produces a new relation, and the new relation will have title ID. Now title ID will again do natural join titles. So once it does natural join with titles, then you get like which person worked in which movie. And then I'm saying, okay, you have the final relation, then you do filtering operation, like where name is like this and ordered by, okay, this got hidden somewhere, but I had ordered by this and order by premium as well. So it does this thing. Okay, now it shows up, right? A better way to do it would be using nested queries. I will just take 5 minutes to end this because the doubt class will start. So a way to do it using nested queries would be you do select primary title, comma premiered, okay, my computer froze. Premiered from title, where you say title ID in, then this is the part when nested query starts. You say select title ID from people, natural join, what was the crew, where name like Brigade Bardot, right? And then you say order by premiered, descending, and limit 10. Okay, it's title. So this is how it does, and this will be a much faster query because you are doing filtering in the first place. Over here, you are not doing natural join with the titles query, right? But you're still doing natural join with the crew query, which takes up time. So another thing is you can do one more nested query. You can say, I will show it to you. So this part is clear in the meantime, right? Do you guys have any doubt in this thing? Like this is giving you one relation, right? And you're saying that this in the particular relation, that is the only thing that you're mentioning. So this will give you one relation where title ID. So this was pretty fast compared to the previous one. It will give you title ID. So you will get the list of title IDs, and then you say you only select title IDs which is contained in this list. To speed up this process, you can say select title ID from people, where person underscore ID in select person underscore ID in crew from crew, sorry, from crew where name like Brigade Bar dot. So it's running 3 loops. It's doing first filtering over here from person ID. Then once it gets the person ID, it will do the filtering on title ID, and then it will give you the fetch you the result. So that's the three-way filtering it's doing. So it's nested query 3 times. So this is one way to do it. There are other ways to do it as well. We will discuss about it in the next lecture. So any doubt till here, like in nested query? Okay. So I guess there is one more meeting you need to join. Like it's for doubt leading session. So if you want to leave, you can leave, and if you have some doubt, you can stay over here. But this will also give you the same result. I will continue with nested query again in the next session, so that things are clear. So it's like if you guys want to drop, you can drop for now. We can do it the next time. Okay. See you guys. You just use SQLite 3 and space the name of database.
I guess you did something like column on, and there was something like mode also. What was that?
Oh, so that was just for visualization purpose.
So could you repeat that? What exactly were those commands?
Yeah, I'll type it down.
Could you please scroll up a little bit? It's not on this. Thank you.
So you want this query?
Yes, sir. And sir, when I do like SQLite 3, then the name of database, and then after that, when I do dot tables, nothing shows up.
Are you sure you downloaded everything correctly? Just check the size and things like that.
It was pretty huge, like around 300 MBs for the zip file.
Hmm, it should have shown like which version of SQLite are you using? Which are you using an Ubuntu or
Windows.
Mac? Windows? Okay. So I don't know, like Windows could have its own commands or issues. Um, should have worked, but yeah, I would Google it like why is my tables not showing with when I open, like, or there could be some different command to open in Windows. I'm not sure. Like you could check that as well. Okay, guys, I guess this is taking the longest time. Uh, so it takes forever. So I guess then natural join is much more efficient way of doing. Not it's not like we have multi-level nested queries, then it breaks things up. So I will just cancel this operation because it's taking memory, a lot of memory. But essentially, this is where how the things will work, and like we have shown it over here as well, like how it works. There are a lot more to nested queries. We will do it in the next class. Like for now, I would say like you join the doubt clearing session. It's going on. Okay, we will continue from here again. Don't worry. Okay, I'm going to end this meeting now.